Hey, how's it going? Today in this video, I'm going to be talking about PGP, or Pretty Good Privacy, and what that is. I have recently came across this particular method of encrypting data. I have done a little bit of research in different areas on how to perhaps having more privacy, especially for your emails or text-based information that you are sharing, and how to improve some of the systems. It's always something that I was looking for myself, or either develop that or some of the markets and what are potential opportunities or companies that offer those services. Uh, if you would Google it, you would find those. Some of the people out there who have developed free services. I believe those services are free. I have tried using that, and you can have that to cover all your emails if that's something that you are interested in. If you're worried about it, and perhaps there's always a reason why you should focus a lot on encrypting some of the data that you are sharing or sending in emails, perhaps based on what kind of emails you are sending, and if you're sharing very important information, and perhaps all information should be encrypted in the first place, and so nobody else can see that. From there, if you're sharing some information that potentially is very valuable, perhaps it can cost a lot of money for your business, right? And you need to think about the systems for your business, as well as non-disclosure agreements. That's really perhaps one layer of protection, as well as once that's been signed with different organizations up there or business partners, as well as perhaps having all the email data encrypted. If anything, where else would you start if not with that, right? Pretty Good Privacy is a data encryption and decryption program that provides cryptographic privacy and authentication. It is often used for securing emails, files, and other forms of digital communication. Pretty Good Privacy used a combination of systematic key and asymmetric key cryptography to achieve these goals. The way how I understand it, usually the way how it works, your the problem that this system is looking to solve is something that's called a handshake. So the person who you're gonna be sending an email to, they need to have a code, and you need to have a code. So when you're sending all the information, that would be text or images or whatever you might be sending in, that information would be scrambled, and later to put that information back together, that other person, other party need to have the same code that you are having. And what will happen, it will happen a handshake, something commonly known as a handshake, I guess, and that person would be able to read that information. And how exactly they developed this kind of solution to this particular problem, we delved into more detail in just a second. Just so you are aware, quantum computing most likely would be able to break most of the codes up there. So whatever information you are sharing, perhaps worth mentioning that once it's up there, most likely someone will be able to read it and see it. If not right now, perhaps in the matter of 4 or 5 years, perhaps 10 years, as well as Freedom of Information Acts and everything. So whatever information you are sharing, you need to perhaps assume that at some point that information someone will be able to read it. Perhaps if we are talking in a business context, if not right now, in 4 years, perhaps you can share some information then. Potentially it won't be that valuable 4 or 5 years from now. But either way, once that information is up there, most likely more people can see it than you can imagine. Let's take a look at some of the components of Pretty Good Privacy. Key pair, PGP, use a pair of cryptographic keys for each user. Public key, this key is meant to be shared with others. It's used for Encrypted messaging files and only the corresponding privacy key can be decrypting. Private key. This key should be kept secret. It's used to decrypt messages or files that were encrypted with the corresponding public key. Digital signatures. PGP allows users to digital, digital, digitally sign the messages or files. This provides a way for the recipient or verify the authenticity of the sender and ensure that the message of the file has been tampered with during transit. Overall, if I don't know if that would work, but it's something that more government companies are requiring for some of the information that I'm sending to them, or other businesses might be interested in sending to them, to all information to be signed with using digital signatures. It's something to be aware of, and there are some free softwares out there. It's just that perhaps having reputable organizations out there who potentially can hold your signatures. That's another problem, I guess. Web of Trust. PGP relies on decentralized trust model called Web of Trust. Users can personally verify the authenticity of each other's public keys by signing them. This creates a network of trust where the key is signed by the people you trust. I mean, again, I need to understand a little bit better. Key services. Public keys are often uploaded to the key service, which are online repositories. So it's potentially those keys are held in instead of cold storage, right? Offline. If those keys are held online, it's never a good thing. Where users can search for and obtain public keys. Key servers help facilitate the sharing of public keys. Email integration. PGP can be integrated into email clients like one that I find, but perhaps there is a more that I do not know of. If you would Google it, you would find it. Well, the project that I'm talking about. Email plugins is something that I was looking for, and I find this particular project. This allows users to sign and receive encrypted and signed emails. For encryption, PGP can also be used to encrypt and decrypt files directly. You can encrypt files with someone's public key, and only they, with their private key, can be decrypted. Passphrases. Private keys are typically protected with passphrase. To add an additional layer of security without the passphrase, even possessing the private key won't allow decryption. Symmetric encryption. In addition to asymmetric encryption, PGP often use symmetric encryption for actual data transmission. A random symmetric session key is generated for each message, and this session key is encrypted with the recipient's public key. For those of you who are interested in learning more, I have published a book with regards to fitness. I'm looking to share this book and information in this book with as many people as possibly can. It's the reason why I've done this work. I have studied the particular field of fitness for many, many years, as well as I gained formal qualifications in this field. And I'm looking to share information that at once back way back I was looking for, right? So I'm looking to pass this information and all the work that I have done in this area of work for many years. I have one of the reasons why I have got into this area to understand this particular area to the best of my knowledge and pass this information in book format, right, with as many people as I can. You can find this book in the description below, as well as Top Retailers has it. To use PGP, you will need PGP software. You can find everything online. And now when I think about it, I don't know if I've done enough research to understand this company and some of the software solutions. If anything, do your own research, especially if we're talking about very sensitive information. I haven't. My intention is not to cause anyone any financial damages with some of the projects out there. This particular project, this seems interesting, and some of the project problems that I'm looking to solve for myself. So I thought it might be worth sharing with others. You will generate your key pair, share your public key with others, and use their public key to encrypt messages or files you want to send securely. The recipients will then use their private key to decrypt the message on file. Thanks for watching. I'll see you next one.